Okay, welcome back, class. Today we're going to be talking about circles and some formulas related to circles. So to kind of start out, the preface to several of the problems we're going to see here today is the situation right here. Lance owns a fly-rite company. His company specializes in making parachutes and skydiving equipment. After returning from a tour of Timberlake Gardens, he was inspired to create a garden in a circular drive in front of his office building. Lance plans to hire a landscape architect to design his garden. The architect needs Lance to provide the area and circumference of the proposed garden so the architect can estimate a budget. So in order to understand this unit, there's a few things that we do need to remember from our previous unit on circles, specifically the difference between the radius and the diameter. Recall that a radius of a circle is the distance from the center of the circle, sorry, that's not drawn very well, to any point on the edge of the circle. So this could be the radius. The diameter of a circle goes from one edge of the circle through the center to the other edge of the circle, and that would be our diameter. And then we do need to know the relationship between the radius and the diameter. We can see from this diameter here that there is a radius on each side, which means that 2 radii equals 1 diameter, or you could say that the length of a radius is half of the diameter. Now, the two formulas that we're going to work with today are the formula for circumference and area. Circumference is what we would call perimeter on a polygon. In a circle, we call it circumference. The formula for circumference is pi times diameter. The second formula we need is for the area of the circle. Remember that the area is the space inside the circle. So I'm going to make a little note here that this is the inside space. And the formula for the area of a circle is pi times radius squared. So you will notice that one formula uses diameter, whereas the other formula uses radius. But remember that the diameter and radius are related, so you can find both of these regardless of which piece of information you actually have. The last 3 items on here are things that we're going to be talking about tomorrow as we kind of dive into these a little bit deeper. You're going to find, Okay, so here's our first example. Going back to the situation that we had started with, I'm going to change my color here. This is the grassy area in front of the office building, and they want to build a circular garden inside this area. Now, some of the dimensions that were given, we can see that this grassy area is 32 feet long, and we also see that it is 27 feet wide. We want to determine what is the largest circle that can fill in that grassy area. And then with that, we're going to find the circumference and the area of that circle. So we could draw a variety of circles in here. We could draw a really small circle. We could draw one much larger. But the question is, what is the largest circle that can be drawn? Okay, think about the diameter, and I'm going to erase all of these for just a moment here, but think about the diameter of this circle. If I wanted this circle to fill up the whole grassy section from top to bottom, then this circle would have to have a diameter of 27 feet. Now keep in mind that a diameter is going to be the same everywhere in a circle. So if I say the diameter is 27 feet, then that means that the diameter going across is also 27 feet. We want to make sure that this circle actually fits inside this grassy area. In other words, we need to make sure that this 27 feet is less than the 32 feet that it's wide. So the largest circle that we can build is a circle that has a diameter of 27 feet. Now, if the diameter is 27 feet, then the radius is half that. Half of 27 is 13.5 feet. Once we've established what size this is going to be, now we can come down here and find our circumference and our area. I'm going to be asking for answers to be given in 2 different formats. One of the ways that we will most commonly give answers is as an exact answer, and that simply means that we're going to leave the answer in terms of pi. A less common method would be to actually give a decimal answer, and for this case, we're going to round our decimals to the 100th place. So going back to our formulas, circumference is pi times diameter, and we're given a diameter of 27 feet, so we're going to do pi times 27. Now, when you're given when you're giving an exact answer, you're going to leave the pi in the answer. But just like a variable, you should always have the number before the variable. So in this case, we're going to switch it around and put the 27 before the pi. Circumference, being the same as perimeter, is going to have units of feet, but not squared units. Okay, so that's my first answer. This is my exact answer in terms of pi. For the decimal, this is going to have to be rounded, so I'm going to use the approximate symbol. For the decimal, I'm just going to grab my calculator. So when I put this in my calculator, I'm just going to type in my 27 times pi, and we're going to get approximately 84.823. Now, since I said round it to the 100th, that's 2 decimal places, so I'm going to round it to 84.82. Please make sure that you use the pi button in your calculator, not 3.14. Okay, so please, for pi, I don't want you to type in the 3.14 because it's already a rounded decimal. Instead, I want you to identify the pi button on your calculator. For most of you, you're going to find this little, what we call a caret symbol, and the pi button is right above that caret symbol, so you're going to be using that button. Okay, so again, use the pi button. It's more accurate. We still have units of feet. That's my second answer in the rounded format. Okay, so for each one of these problems today, we're going to give the answer, in most cases, in both of these formats. The second part of the problem was to find the area. Area, remember, is pi r squared. This time we're using the radius of 13.5, and we're squaring that. If we square 13.5 in your calculator, you're going to get, 882.25 pi. Again, always put the number before the pi. Area is squared units, so that's going to be feet squared. That is my exact answer. For my approximate answer, I'm going to multiply my 182.25 times pi, and that's going to give me approximately 572.56 when I round it. Okay, so most of the problems today are just going to be your basic use of these two formulas, but in some cases we're going to look at some actual examples of when we can use these in real life. So as we look at this next example, now Lance has decided that even though he knows he can make a larger garden, he's decided he is going to stick with a garden that has a diameter of 20 feet. The landscape architect that he's meeting with recommends that he should surround that garden with this decorative edging. The edging is sold in 12-foot sections that can be bent into curves. We need to figure out how many sections of edging he's going to need to surround the garden. So remember that we're dealing with a circle that has a diameter of 20 feet, and we want to figure out how much edging is going to go around the garden. Anytime we're talking about the distance around an object, we are referring to the circumference. So the first thing I need to find is the circumference. Circumference is pi times diameter. My diameter is 20, so my circumference is 20 pi. Again, if I want an exact answer, I can leave it as this. If I want a decimal, I'm going to multiply 20 times pi in my calculator, and I'm going to get approximately 62.83. Now, this question is asking how many pieces of fencing does he need to go around the border. So it's not asking me for the actual circumference, but how many of these 12-foot sections do I need to go around this border? So I know that it's a total of 62 feet around here, and I have to figure out how many of these little 12-foot sections go into the 62 feet. If I divide by 12, I'm going to get approximately 5.24 sections. Unfortunately, you can't walk into Menards and ask for part of a section, so we're going to have to round that up to 6 sections of fencing, and we're just going to have a little bit extra when we're done. A second example, again, remember, this is all about budgeting for this landscape architect here. So now Lance has decided, okay, he's ready to build the garden. He knows how much edging he needs. He knows what size it's going to be. He now needs to fill the inside of the garden with soil, okay? He knows that each bag of soil can cover 3.5 square feet of the circle. We need to know how many bags of soil can he buy. So once again, we're talking about a garden that is a 20-foot diameter, okay? This time, I want to know how much soil we need to fill up the inside. So again, inside is area. We're looking for the area, and we can find area by doing pi times r squared. If the diameter is 20, that means that the radius is 10, and it's the radius that we're plugging in. So we're going to do pi times 10 squared. 10 squared is 100, so that's 100 pi. Again, as an exact answer, I can leave it as 100 pi. My area is squared, so that's feet squared. If I want the decimal answer, I'm going to multiply 100 times pi, and I'm going to get approximately 314.159. Now again, that's the total area, but I need to figure out how many bags of soil do I need. Each bag covers 3.5 square feet. So if I divide this by 3.5, I'm going to get approximately 89.759 bags. Unfortunately, again, I can't walk into Menards and ask for part of a bag of soil, so I'm going to have to round that up and say that I'll need 90 bags of soil. Okay, so final step here in our problem is that Lance is deciding that he wants to put a sidewalk around the garden. That way people can walk around it and admire the flowers and all of that. So he's got to figure out the area of the sidewalk alone. Okay, now keep in mind the area of the sidewalk, I'm just asking for this shaded part of the picture. This is the sidewalk going in a circle around the circular garden, and I want the area of only the shaded region. Thinking back to what we did on Friday, if I find the area of the large circle, so I'm just going to circle that one. If I find the area of the large circle and I subtract the area of the smaller inner circle, so I'm going to subtract that smaller one, that should give me then the area of the shaded region that's left. So think about the smaller circle. The smaller circle is the garden. The smaller circle was the garden that had a diameter of 20 feet. We knew that the radius was 10 feet. We knew that the area was 100 pi feet squared. The larger circle is going to have a radius. If you go from the center and you go out to the edge here, this is 10 feet, remember? But now I'm going to go an additional 2 feet. So that means that the radius of the larger circle is 12 feet. Now, if I want to find the area of the larger circle, area is pi times radius squared. If the radius is 12, that's going to be pi times 12 squared. 12 squared is 144, so that's 144 pi. Now, since I want to subtract these two, keep in mind you can subtract them in terms of pi. 144 pi minus 100 pi is going to be 44 pi. So my exact answer is that the area of the shaded sidewalk is 44 pi feet squared. My approximate answer would be multiplying 44 times pi in your calculator, and you would get about 138.23 feet squared. So what I would like you guys to do is take a couple of minutes and try these quick problems. There are 2 problems here. I want you to give me the answer for each problem 2 different ways. So you're going to give me the area as an exact answer in terms of pi. Remember that exact answers in terms of pi, since they're exact, we're going to be using the equal sign for all of those. But then I also want you to give me a rounded answer, a decimal, in other words, rounded to 2 decimal places. And since we're rounding those, that's when we use that approximate symbol. So you're going to give me the rounded answer for each of those. When the sub today is going to have a copy of this little handout. When you're ready to try these problems, please go up and get a copy of this little exit slip from the substitute. You're going to try these problems. Please put your name on it and then return it to the sub at the end of the period. I'll be able to check those this evening, kind of make sure we're all on the right track, that we're understanding these two formulas as we start the next. Your homework for tonight then is the Delta Math that you'll see when you go into Delta Math. Make sure that you're doing the one on circumference and area. So it's going to be the Delta Math on circumference and area. And we will see you guys tomorrow.